Okay, so I thought it'd be interesting to do a quick review of first revision DNA sequences. So what I mean with that is by that is the like the first version of a DNA sequencer that comes out for a particular technological approach from a particular company. Um, so this would be, a new instrument that has been introduced into the market to sequence DNA in a new way. Um, and the instruments I'm going to look at are the genome analyzer, the ABI solid, the 454 FLX, which those three all came out around the same time, as we'll see in the next slide. But also the Ion Torrent PGM and the PacBio RS2, which I think we'll just talk about very briefly because I don't have much information on it. But those two instruments, the PGM and the RS2, came out much later, and you can imagine that would probably mean there'll be some technological differences between those instruments in approach. This again kind of puts it all in context. You can see on the left here the solid, the GS20. We're actually going to talk about the FX Plus, but they look very similar, and I'm going to assume they're a similar technological approach. The Genome Analyzer 2, again, Genome Analyzer 1 and 2, and the various versions of the 2, whatever it is, the X and the E. As far as I'm concerned, they're all basically the same platform with minor differences. But we'll talk about those three instruments, and then the PGM, which was released kind of roughly 5 years after that, and the RS, which was released kind of 6 years after that. There's some variance in these dates for sure. So we can see on the bottom left here, the genome analyzer is this boxy instrument here with the Illumina branding. There was a previous version which said Selexa on it. I'm not sure if any of those still exist. They were all kind of, the covers were all switched out after the Illumina acquisition, is my understanding. But you can see it's kind of a lopsided instrument. There's this, the optics is towards the right side of the instrument here, and there's this big empty looking, well, there's this big gap on the left, and that's what you can see. What you can see on in the center of this picture is like the sides of the instrument come off, and if you take off the left side, this is what you see. Essentially what you're looking at here, as far as I'm concerned, is a bunch of lab equipment that has been just thrown in a box. And I guess I know some of the people at Selexa and some of the personalities involved, and I feel like there probably came a point where experiments started working at that company, and there was pressure to get an instrument out to meet their milestones with investors or whatever, and someone just went into the lab with their kind of lab rigs and just said, throw it in the fucking box, get it out the fucking door, throw it in the box, and we'll just get it out of here. Like, just ship it, like that, and I think some of the people involved are a bit, have those kind of personalities maybe. So that was always my image of what happened. But I don't know, Selexa was a kind of odd company in that it was split across multiple locations, and there was an acquisition or merger with a US entity. Some of the engineering almost certainly was done over in the US, some in the UK. So, who knows? I'd love to know what the true story is. We've got a few more pictures which we'll go through, but basically here you can see there's a chiller. There's this stage controller, which really looks like a lab stage controller. All these things are taking well, in the UK 240 volts, but mains power. So you know, there's a supply going in here, there's a main supply going into the ASI stage. This is a kind of a syringe pump fluidic system, and I think that doesn't run off mains. There's a power supply, I think, for that. There you can't really see it. Everything is kind of zip tied together, but you can see one here. You can see one of the mains power supplies just zip tied onto the side of a case. I believe there's another one kind of up the top which is just zip tied on. This thing is quite interesting. This is a commercial USB serial adapter, 8-port serial adapter, and it's just had its case taken off. I've bought another one on eBay with the case on. It fits on perfectly to this, but it's just like, it's called an edge port, I think, and it's just a nice little unit that throws out 8 serial port RS-232 serial ports, and it's not TTL level versus like proper RS-232. And they're just all these, because all of this is just lab equipment, which is all just controlled with RS-232. So yeah, there's like 7 RS-232 cables going off to the chiller and the stage, the fluidic system here, and I forget if it goes to one or both of the lasers, which we're not going to talk about lasers here, but there's again commercial lasers from Quantum Gem, 532 nanometer laser on the other side. The one custom part shown in this picture is that PCB, in the center. That's the fluidic system. This is the PCB that was in the center of that last picture, and this appears to be custom. So it's, I think that Altera part is an FPGA. The main microcontrollers here, I think that one's definitely an STM. Is it STM32? I'm not sure. It's probably an STM32. It says ARM on it. So STM32, which is like a cheap, fairly low power, even for 2006, not a particularly powerful microcontroller in my view. It's not like you've got like a full Linux capable PC style microcontroller. Very basic microcontrollers, essentially doing the job of tying everything together. It's working as the control system, sending out messages to everything. I forget exactly how this was controlled. I think the RS-232. There's a USB hub. There's a D-Link USB hub that sits in this system. I think the RS-232 cables all go into that, and this goes into that, and then they all go out to the PC, because there's an external computer that controls all of this, which also has a camera link card to control the camera. This is the RS-232 board. Just a piece of inside out networks, edge port, I think, controller. So yeah, some other pictures, more power supplies. Just a couple other these big bulky power supplies which take mains power and throw out 24 and 12 volts for various things. A big mess of cables with zip ties. Kind of a mess. So what level of engineering, like integration, are we going to call this? I think it's not very particularly well integrated, but it certainly is like a working system. This is the optical system, which I had in my, it's actually behind me now, but on the bottom here, this is the laser box, which sat on the other side. That's basically, I think, there's a laser box on the right side of the unit, and this thing, which is a mode scrambler, which kind of wiggles around the laser beam. I discussed it in another video, and we can see I've pulled out the stage controller. And yeah, this is the same serial port box, but now with a case on it. That's what it looked like when you bought it. They must have taken all the cases off in Selector, I imagine, and zip tied them to the case. On the left here, this is the optical system. So this block sits inside the genome analyzer, and it's a fairly basic optical system. 4 Labs kinematic mount, which is firing a laser or guiding a laser towards the prism. Nikon objective. This has a different objective in it, but it's a Nikon. The one that comes with it is a Nikon objective. It's an infinity optics system. So there's a tube lens. There's the filter block here, which is also from the same company that does the stage controller. So the stage controller does the XY stage here, the Z stage, and controls the filter wheel. Pretty much just probably a slightly customized version. There are interlocks on this stage controller, which probably would not exist on the commercial version of this controller, but it looks pretty standard. You can find comparable parts. And then there's a camera that's not set up here, but was a Coolpix K4 camera with camera link out of the back, which went into a PC. So yeah, all very, in my view, indicative of a lab rig, which was like, yeah, try and get us 10 of these and throw them in boxes so we can do placements at customer sites, and say we're in a user validation kind of phase. So there's that. ABI Solid, not an instrument I've used. Came out again around the same time. I don't have as good. I've never actually seen this one in person. These pictures come from somebody's blog on the internet. So this is on the left. You see the unit they kind of have the compute sitting under it, and the main system sitting on top. The picture in the center is the microscope that someone has pulled out of this instrument. So this is very much just a research grade, I would call it research grade microscope, with a camera attached to it. They've taken off the eyepiece lenses and the what do you call it? Is it not turret? Whatever you call the bit which the eyepiece lenses plug into. So the bit you would look through as a researcher is taken off, and I guess that goes here. So they've kind of covered it up. But it's got standard turret still, which is weird. Like, this is weird to me, because why? There's only one objective here. So why did they need to do this is unclear to me. Maybe they were under pressure to ship. I don't know. You can see the objective sitting straight up there, and I guess the stages, the slides kind of sat here. I don't know if this is a reflection or if this is another objective. I think that's probably just a reflection, right? Yeah. So, yeah. I mean, it looks a bit more custom to me. Like the jigs and things are a bit more. Like, this doesn't look as much like a standard ASI stage. It looks a bit more custom. And in the if you go back to the genome analyzer, the jig here is just this. There's a fairly basic jig for the prism and the flow cell, which is, I think, this bottom bit is Delrin probably, and I don't know what this is, but it's a machined plastic. Whereas this looks a bit more, professional level engineering. It's made by a much bigger company, ABI. They've had loads of resources to throw at it, whereas the selection instrument is made by a startup. So you would expect to see a higher level of engineering, which maybe means it's a bit weird they use this research grade microscope. I don't know, but there it is. I think you can see it's an IX something 81. Something, I don't know. So it's a Olympus microscope. Yeah, and this is one of the better images of the cover off. I would say things are laid out a bit more neatly. There's not as much stuff that's zip tied to the case. But yeah, it's a decent instrument. Okay, 454 FLX Plus, which we're going to assume is kind of similar to GS20, but I don't know. I mean, I have looked at 454 stuff somewhat, but not in any great depth. These pictures come from Mike's Electric stuff. And it's difficult getting good pictures of teardowns. So these are all kind of close up. So ideally I would have liked pictures showing the whole kind of system. But you can see it's got this custom fluidics system. So the stuff we saw on the genome analyzer was, where is it? There it is. Yeah, this thing is basically this valve system is something you can buy, right? That you can just shove in. So they just bought something and shoved it in. Whereas in the FLX, they seem to have built this custom fluidics block specifically for the FLX, I guess. This is what it looks like to me. And these are these are standard valves. I think I have some of these somewhere else. So yeah, it looks fairly solidly engineered. Actually, it looks like a pretty decent slot job. Although, you know, obviously there's pipes going everywhere. There's still, the enclosure keeps everything very neat. There's still wires going around, but I would say it's a bit more neatly kind of tied together than the other two instruments. The central kind of camera here is this Spectral Instruments very fancy low noise camera, which is the bulk of what's going on, and it's directly coupled to the flow cell which sits here. This obviously makes the optical system much easier as well, because there's no objective focusing or filters of stuff. It's what's called a single channel instrument, so it's only imaging a single color, a single wavelength or set of wavelengths of light, whereas the other instruments are looking at different colors and having to use that filter wheel to split out the colors, right? This is a much simpler optical system. There's the camera again. Mike's played with this a fair bit, so you could go check out his videos, which I'll link below. Okay, so that's I think that's a bit better integrated than those other two instruments, partly due to the simplicity of the design, but also partly just because it looks like it's been more heavily integrated. I don't know. That's my kind of take on it. Then we've got the Ion Torrent PGM, which is one of these instruments that was released later. I've got one downstairs, so these are my pictures. So we've got on the bottom right here is what it looks like in the box, and then on the left is the top-down view. The case comes off really nicely on this instrument, so you can kind of expose everything and look at it really easily. On the left hand side we have the compute, and we have the jig in which the chip sits. This is a semiconductor technology, so not to go into it too much, but everything happens on a semiconductor chip. So the DNA flows onto that chip, and it's detected. DNA is detected, or incorporations are detected by changes in pH. So there's no optics in the system, and that, of course, inherently makes it somewhat less complicated in terms of the system design, right? So we don't have to have a camera or optical system here. It just clamps into this jig. And that sits directly on this compute board. We'll talk about that in another picture. But basically, we've got PCI, I think these are PCI Express cards that slot into this board. We've got a USB card, a SATA card, and a video card. And there's a VGA cable that comes out of the video card and goes into this, which is a VGA monitor, essentially. with a serial touchscreen. The touchscreen attaches to the main board. This board runs Linux, so it's pretty much a PC, small PC. It's custom, but it's a kind of computer. It's not an x86 PC. We'll talk about that in a bit. But interesting thing here again is that the fluidic system looks very familiar, doesn't it? If this is the FLX, and they look like the same valves basically, and the same style of optical fluidic block. Both these companies were founded by Jonathan Rothberg, and I kind of imagine either the same engineers are on board to do this, or the fluidics part of the system design was contracted out to the same company. That would be my guess. So I just thought that was kind of a cool point. But yeah, it's very simple. Designed again, it's a simple fluidic system. The fact that these things don't have the same level of optics involved kind of makes them simpler. Looking at that compute board, what you've got is 3 lattice ECP2 FPGAs, which sit under this drip tray to protect the board. There's one here, which is a larger one, and a couple of smaller ones here. And I've written it kind of fairly in some amount of detail on my blog about what the capabilities of these FPGAs would be, and to what degree these could scale out to larger and larger chips. And they did scale out this system somewhat based on the chip. Like, they could introduce larger chips into this instrument and make it do more. But I kind of speculate on where that would have topped out if they'd really pushed it. There's 4 gig of RAM on the left, which I think probably is feeding the FPGAs, the buffer for the FPGA. And there's a gig of RAM on the right, which I think goes to this processor, which is a PowerPC processor. So it's a PowerPC processor running Linux with a bunch of cards. There's an Ethernet port underneath, which then just routes out to the back of the unit. I think it's gigabit Ethernet, but don't hold me to that. So on this side, this is the fluidics kind of sit in tubes that come out the front, that sit on the front, and then you've got the fluidics all feeding it. I don't know why the fluidics is always like so many pipes just floating around. People never seem to route the fluidics quite as well. But then I guess the cables aren't routed great either. So I don't know. I suppose part of it might be with fluidics in particular that you don't want to pinch fluid lines. So if it's rubbing up against things, maybe that's kind of an issue. This I think is a Peltier based chiller for whatever was here. I'd have to look at the instrument to tell you. Oh yeah, this is kind of cool. You can see it just behind on the right. This is a regular PC power supply. This is a Corsair 650 watt ATX power supply, consumer grade as far as I'm concerned. As are the PCIe cards that sit on that PowerPC processor. It's like a Radeon graphics card with a VGA thing coming out of it. Nothing particularly special. On the other side you have the 2 hard drives. Obviously they were using the SVN. So no, this is before Git had reached a critical level of popularity, I guess. But they've got a boot drive and a data drive, and the system would, like, the data flows obviously off the chip through the FPGAs into that, or through the FPGA into that memory buffer, and then somehow through that PowerPC maybe there's like DMA going on, or like I'm not sure exactly what's going on there, to get it into the PowerPC, and then it streams it off to the hard disks, and then that's kind, like, actually you could do a whole run. You could capture all your DNA for a whole run, all of your raw data for a whole run to the hard drive, and then it would fly out through the Ethernet onto what they call the torrent server, not BitTorrent, but the server that attaches to this instrument, which did the primary data analysis. So that's my understanding. There's really not much data reduction, and the data rates aren't super high here, so there wasn't a lot of data reduction going on this instrument. Most of the data reduction and base calling data analysis happened on the torrent server. Yeah, so I think that's kind of an interesting instrument. Okay, what level of integration is that? Well, it's certainly better integrated, I think, than the genome analyzer, and they're solid. Maybe a little bit better integrated than the FLX. I think it looks kind of neater. Some of this is down just to the technological approach again, and I think that's kind of the distinction you see between these systems. Is this is just doesn't need all lasers in a complicated optical system, which has made the whole integration of this platform much easier. Still, I would say there's more integration that's gone on here. They've built that custom board with the FPGAs and stuff, and but part of it is they've had a less challenging system to deal with. PacBio RS2. I can say almost nothing about this. The pictures come from eBay. It's a very heavy instrument. I think it needed some crazy liquid nitrogen cooling system or something as well. But it's huge, isn't it? It's like a ton or something, yeah. One thing we can say is it seems to have a lot of cables coming out the back. These all look like camera link cables. Camera link is a standard mostly used for scientific cameras to get, it's like the FireWire or the USB of scientific cameras. So sometimes you use one camera link cable per camera, sometimes two. So it's not clear. How many cables are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10? So it could be 5 cameras in here or 10 cameras, which seems like a lot. There's a lot of cameras. I bought an unspecified Andor camera. Andor is a company that makes what are called scientific CMOS cameras. And this was clearly an OEM unit. And I asked the guy where it came from, and he said, oh yeah, it's from PacBio, the makers of this instrument. So those are expensive cameras. Those cost like, I don't know exactly, but they're not cheap. Like the PCO Edge is another camera, but I think they're like 50, 100,000. I did look up what it looked. I tried to find out what it was like, and I think it was a Andor Xyla or Neo, something like that. It used a Fairchild image sensor. So those cameras require cooling, fairly substantial kind of cooling, as I understand it. If you've got this many cameras in the system, and you've got some fairly high-powered lasers as well, I guess that's why it needs a ton of cooling. And you're possibly wanting to cool that stuff down, and and the lasers as well. And I don't know what temperature the flow cell needs to be at, but there may be something involved there, which may make this thing so big and heavy. And so now, right, if you don't know anything about the how successful these instruments are, which one guy on Discord, which is where this talk came from, I think possibly doesn't have a huge amount of background in these older instruments. So if you don't know anything about that, I would advise you to stop the video and think at this point, which do you think is your favorite instrument, I guess, the best engineered, and speculate on which might have been the most successful instrument. So yeah, stop the video and join me in a second. Okay, hopefully you've come back. So the most successful instrument of all of these was the genome analyzer, quite obviously. Genome analyzer led to the most successful line of instruments in DNA sequencing to date, which are now sold by Illumina. So Genome Analyzer in 2006, and then the HiSeq in 2010. Various iterations of a HiSeq, and then I don't have it on this chart, but the NovaSeq, which is kind of an iteration of a HiSeq, NextSeq, MySeq, probably together, like Illumina, you can find various numbers, but clearly 80 plus percent market share. But in terms of engineering, it's clearly not the best instrument. It's clearly, in fact, one of the worst instruments on this list, with, you know, these multiple power supplies and basically being a lab brick shoved in a box. But none of that matters. Not important at all. Much more important that they shipped something, the performance was where it needed to be competitive in the market at the time, and that the basic technological approach was superior. So all of that trumped engineering excellence. I'm so sorry. Yeah, that's it. Thanks for listening.